The machining of the wheels is the beginning of the journey for the bullet train. It ends up like this, a brand new bullet train. And once built, it's ready to take its first high-speed journey. I wonder if they've left the keys in. Here it is, the business end. I'm guessing flat out. At what, close to 200 miles an hour, 300 kilometers an hour. Being a train driver is quite exciting again. This might be in the workshop, but it is actually wired up and ready to go. It'll be driven out of here. But not now, not by me. Probably just as well they didn't leave the keys. But what happens when you do switch the train on? To move at all, let alone reach breakneck speeds, the bullet train needs power. And it gets all the power it needs in the form of electricity from overhead lines. The connection between the wire and the train is this device along here, the pantograph. So electricity flows in through those few square centimeters where it touches the wire, and from there, down into the train. To feed enough power, engineers faced a choice between a faster or a bigger electrical flow, stepping up the voltage or boosting the current. In a lab that looks more like the set of a sci-fi movie, Manchester University professor Ian Cotton shows the demands big currents make. So Ian, talk me through this. I'm guessing current is going to go around there somewhere.
Yeah, so we have a transformer from the mains, and in this loop we get a high current.
All right. Well, fire it up then. Is it working now?
It will do. You'll see the numbers on the ammeter go up, so that means we're getting more current flowing through the loop.
So this is the quantity of amps flying through here. Oh, hang on, look already. This wire is getting hot. What's happening? High amps, a big current, overload the thin wire. It heats it up to the point of complete failure.
So if you have very, very high currents, you need to use a very big piece of metal to let the current flow.
So for our train, we'd need much bigger than this?
Absolutely. It would be very, very big and very, very heavy.
To carry enough current for the bullet train, the overhead wires would have to be huge, thicker than a man's arm, and enormously expensive. Totally impractical for train lines that run for hundreds of kilometers. The only other way to give the train the juice it needs was to up the flow, the voltage. Train lines usually carry 1,500 or 3,000 volts, nowhere near enough for a bullet train, so the engineers increased it to 25,000 volts. But with such a gigantic voltage, any break in the circuit between the wire and pantograph can be catastrophic.